All right, well, welcome to a presentation of near real-time outlier detection and interpretation. I'm Bob Thorman. I'm with AT&T. I work in the Chief Security Office at AT&T as a principal software engineer, specializing in the area of applying big data technologies to threat analytics and threat management. Privileged to have Adam Fuchs with me. He's the CTO of Squirrel Data Incorporated. Known Adam for a long time. In some sense, he's been kind of a mentor to me in the area of big data. He's been an innovator in big data for a long time. He's going to help me talk about the implementation details of using Squirrel Enterprise as part of our threat management platform. But when we get through here, I do want to say before I get into my slides that I now know that Hadoop is transforming the way we as software engineers, the way our industry works. I saw a Microsoft guy presenting his work with IntelliJ in Java. I can't hardly get over that. That's transformative. But we're going to talk about some other transformations in the way we do threat management, threat analytics. I want to set a brief context real quickly about what kind of network we're talking about in our industry when we talk about threat analytics and threat management. Give you a little history of AT&T's journey through that, and then we'll talk about this Hadoop-based approach and look at a couple of examples at the end. Adam will get up in kind of in the middle of this and talk about the implementation details of what lies under that. But let's look at the problem of cyber analytics, or cyber threats in our industry. If you were in the keynote address, how many of you heard Adam Winchell talk from Capital One talk about the problem of cyber threats? He described the context perfectly of the way I want to set the stage of what we do in threat management. And that is, the network is very, very complicated. We deal with an enterprise network. I'm not talking about AT&T's mobile network or our wireline network we offer customers. I'm just talking about in general. Our industry suffers from huge, complex enterprise networks the way we do business. We're talking about nearly 1 million authenticated users on these enterprise networks. Almost that many user-oriented devices at any one time. And literally hundreds, if not thousands, of devices on the network. Not just switch gear and the things that it takes to move the bits and bytes around, but protection systems, protection devices, and firewalls, and all those things make for a very complex topology. And protecting all that is very, very difficult. The situation around us is illustrated really well in this graph. Not what's inside our enterprise network, but what's around us that drives the need for a big data-based threat analytics and threat management platform. And it's illustrated here in the amount of data that you can see just associated with one type of cyber threat. And these are reflective DDoS attacks. And this is over the last 30 months of how much traffic goes around the wild internet just associated with reflective DDoS attacks. And if you look to the very far left, you see that green spike over. That's 2013. That was a remarkable year in cyber attacks. If you happen to remember, that's when the term anonymous, well, it became not. Everybody knew that term. That was when the Colombian government was attacked at a massive scale. Their government was essentially shut down in 2013. The target company lost 40 million debit and credit card credentials that year. Spamhaus went nuts in malware campaigns in the tune of hundreds of gigabytes of data over the internet. So you look at that spike and you think, wow, that was a crazy year, until you slide your eyes to the right. That's normal. It's normal today. Right? That amount of attacks and threats out into the network that we have to defend ourselves internally is now normal operating business. So we got our work cut out for us. So a little bit about the history of how we've had to answer that situation. Well, I did a little research in AT&T's program history, and not so long ago, back in 2002, we're really dealing with millions of events per day. And if you heard Adam Winchell talk about hundreds of millions of events per hour, that's where we've fast-forwarded to here in just the last 15 years. We've fast-forwarded to millions of events per hour, where before we were only dealing with that many per day. We're looking at next year talking about trillions of events per day. That's some massive scale of data that we have to deal with in terms of handling the threats that are against that might come against our network. We've had some major developments going on at AT&T of getting from the traditional relational-based systems over to a Hadoop-based ecosystem. And some of the notable major events I've listed here, not the least of which was the release of the Apache Accumulo project, which is a highly performant key-value store, which is the underlying implementation of Squirrel Enterprise that we have teamed with and partnered with to make our threat management platform. And we have now delivered to our enterprise the first Hadoop-based ecosystem for a threat analytics platform. So let's get into a little bit of the details about how this has changed things. So in the past, our threat management platform looked like this. It was highly dependent upon SIEMs, Security Information Event Management Systems. It was largely a data reduction system. It was some smart software reducing massive amounts of network events down to threats. We would pour those on to as much SAN storage and relational database as we could throw at it, and it simply gives an analyst the ability to ask questions, a query engine of, hey, what is going on in my network? Highly cognitive based, a lot of analysts involved in that. And just to the point where they had to start recognizing threats. Clicked the wrong thing. The challenge is and was that the process to determine from all that information what is a true threat was largely cognitive. So there's a lot of folks sitting around just protein processing those events and trying to figure out if there's actions we got to take, remediations and policy changes to apply. And this becomes the template for us for automation. The area of detection and interpretation are those areas that we're taking the Hadoop technology, the big data technologies, and focusing on automation so that we can reduce this task. So how are we doing that? The Hadoop-based approach. So we've moved from a SIEM-based platform that's largely dependent on a relational database system and into the Hadoop ecosystem. So what this puts us into is not a data reduction, but an entire data warehousing approach, moving from the left. Everything becomes a source now. Since we can warehouse that on a scalable platform, everything becomes a source of information. In the center, the Hadoop ecosystem, again, ours built on Apache Accumulo and the implementation that Squirrel brings us, becomes an event processing, analytical environment that we can begin to alarm analysts on threats by doing this detection and interpretation, all of which is backed by scalable raw log storage. We can always get back to forensics, deep learning, all those behavioral analytics that we need, and of course supported by a visualization layer. Now before I go into examples of how this has changed things in AT&T, I wanted to let Adam talk about the implementation details of how Squirrel Enterprise helps us with the whole threat analytics platform.
All right, thanks, Bob.
You bet. Mic change.
Hello. Should I speak louder? Okay, there you go. All right. Okay, so I'm Adam Fuchs. I work for a company called Squirrel. We do kind of general cyber threat analytics. Been working with Bob and his team for a while here. And Bob and I, as Bob mentioned, we go way back to my days working on the Accumulo project. I still am a committer on the project, but I was one of the original developers and kind of led that into the open source at the Apache Software Foundation, where I'm now a member as well. So if we take AT&T's case here, where we've got tens of billions, scaling up to trillions of events per day that we really need to analyze here, that's a big problem, right? There's a lot there's a lot of endpoints to connect here. You got to bring the data in, you got to connect it with analysts, you have to do automated analysis in the background. What I do at Squirrel is I try to build a system that kind of takes all of that together and largely based off of Hadoop and Accumulo and other ecosystem projects. Really, we try to pull that all together and make it really easy and feasible at these very, very large volumes. So that starts out with a data organization. So you'll see a lot of people these days will do analysis on log data. How many people do analysis on log data here? Pretty much everybody that's doing analysis these days is doing analysis on log data. For log data that's up into the hundreds of millions and billions, and over time, tens of billions, hundreds of billions of events, you can kind of do search and some transformation of that log data and develop insights into it. A lot of times when you scale up into the trillions and tens of trillions of events over long periods of time, it's really difficult to get rapid insights into what's in that data. So you might be able to analyze a small portion of it for a subset of use cases. But when you're talking about cybersecurity analysis, you have to adapt very quickly. So Bob showed the growth of some of these analysis use cases over time. And what that really means on the analysis side is that the faster you can add a new analytic to your system and really understand what's going on behind it, the better you are to keep up with the threats. So what we try to do is we take that log data and we also calculate a summary of it in a graph form. So we see what entities exist across all of those logs, and we try to calculate some semblance of their behavior in a graph form. So while a particular host might have 1 billion log records associated with it, it might have one entry with hundreds of features associated with it in a graph view. And that becomes a very quick summary on top of which you can do higher level analytics. So at the core of our platform, we do that combination of a log data approach and a behavioral graph approach. To really manage that and make it available to analysts, we bring that together with an analysis platform that's very much UI based, so allows exploration of the graph, drill down into the underlying logs. There's also an analytics engine and a risk engine that basically is machine learning, where we do automated analysis of this. And really everything is glued together through that graph representation, the linked data representation in the middle. Right. So the architecture that we use to support this is largely based on Hadoop. So if you look at this as sort of a layered model of how we bring it all together, starts out with being able to have a scalable hardware platform. Right? The Hadoop community has been oriented towards commodity hardware and kind of scalable pizza box style large clusters since its inception. So we've continued with that, and on top of that, we organize the data into Hadoop distributed file system. On top of that, Accumulo, right? Accumulo being sorted key value store. I'll get more into that. Then we have the raw data and the linked data views, so kind of the data organization model. On top of that, processing architectures that include both real-time search engine type interactive query analytics, largely built on Accumulo iterators. And then we're using a lot of Yarn and Spark and MapReduce processing as well to organize the events and to do automated analytics. All that being capped by a visualization layer that Bob will show some of those elements later on. So the Apache Accumulo project is a core of our platform, not just because that's kind of my roots and where I came from, but because Accumulo provides a natural glue between some of the large-scale automated analytics of very large corpuses of data and the interactive real-time organization and visualization that we want to do on top of that data. So Accumulo, who's familiar with Accumulo in the audience? Okay, good. So a fairly good group here. Accumulo is a clone of Google's Bigtable. It's oriented towards storing sorted key value pairs and scaling that up to tens of petabytes, thousands of nodes, all while providing low latency lookup for ranges of keys and very fast ingestion of data. So really, we're leveraging Accumulo to provide that low latency information retrieval. So the sort that goes in at ingest time allows us to do very quick lookups to find the things that we're interested in. that's basically the indexing story. We also do a fair amount of distributed processing in Accumulo. So since it's in the Hadoop community, it's tied to MapReduce input and output formats that kind of give us this entree into Spark and other distributed processing infrastructure. But also built into Accumulo, there's this concept of iterators where as we ingest data, we can basically aggregate that information and do a bunch of interesting statistical aggregates, largely at ingest time, to provide more interactive query later on. So let's talk a little bit about the behavioral analytics. So once we've organized this data, we stored it in Accumulo, we've got a graph model and a log model of it. Then we got to talk about what analytics do we perform. For the security domain, we're not just doing kind of general machine learning, but we're really tailoring that machine learning towards specific behaviors. And those are oriented towards an attack chain. Right? So if you think about an adversary coming in, they have to do some reconnaissance to figure out what's in the network. They have to build some type of exploitation, deliver that, actually exploit the systems that they're attacking. And then they move on to things that kind of produce some noise that you can catch by log analysis and graph analysis. So command and control, where they're beaconing back to some type of command and control server, the lateral movements associated with moving from one host to another in a network that they've already exploited. If we take that general adversary behavior and we try to decompose it into a bunch of these small steps that they take, that becomes a very natural way that we can organize our approach to machine learning in this system. So if we take an example of that, maybe I'm looking for a lateral movement, right? So maybe somebody did a phishing attack on my network. They got in through one of my employees that probably shouldn't have clicked on that email, but they're in now. Now they've got to go find the interesting bits inside my network, and maybe it's squishy on the inside, hard on the outside, so it's easier for them to move around. But as they do that, I still log things, right? I still have data sets that are really capturing their behavior. So those might be Active Directory logs, or Windows event logs, or syslog from my Linux servers. When I take those data sets and I want to analyze them, I need to provide some algorithms to analyze them. So I do maybe some unsupervised machine learning, determine which of these login events is rare relative to the overall corpus, and then I can do graph algorithms to kind of form these into larger networks. Right, so if we take that behavior that we're targeting, apply a data set that exhibits elements of that behavior, find an algorithm that really teases out of that large data set the behavior we're looking for, and we can roll that all into the graph, right, and tie it back into that overall system for doing a complete analysis with the context. Right? And then this becomes a place where we can interact with the analyst and provide feedback to the system, like whitelisting something or taking further action on true positives. So that collation of all of the results, gathering them up, pulling them back into the system is a huge part of really completing the story. So if we think about really adapting to adversary behavior, over time there are going to be many, many of these analyses that we want to perform, right? Many, many behaviors that we want to detect. And if we have to have sort of a separate analysis screen from each of those, now I've got a bottleneck in my analysis, which is my analyst's ability to consume the results. So the answer for that on our system is to tie those back into entity risk scoring. So while an analyst might not be able to consume 10,000 detectors and all of the detections that they produce, they can consume a set of ordered, high-risk entities. So you'll see a lot of security companies these days moving towards that risk-based model, largely to be able to scale up the analyst's ability to consume all of these results. So feeding that back into the graph, combining it with the raw data, providing visualization on top of that to really tie everything together and to be able to do forensic analysis once you've identified, there's an interesting event on your network. That's really what Squirrel is all about here.
Very cool. Thanks, Adam. Appreciate that. And it really is what it's about, is getting the analyst's eyes on the right information. There's just too much information to look at these days. I'm sure there always has been. So I got just a few minutes to show you a few examples before we'll open up the floor to some questions and hopefully some answers. No heckling by the AT&T crowd. Okay. So I do have to be very careful about attributing this data. So there's a lot of anonymization that's gone on into these, but these are some real-world examples. And one thing I want to take on here real quick is what I mean by near real time. And I'll define that in a highly technical term. Pretty damn fast is the way I'm going to define that. This stuff happens in milliseconds where it used to happen in minutes. It happens in seconds where it used to take hours and sometimes days. The indexing that goes on using this Hadoop ecosystem and things like Apache Accumulo provide for some very fast performance. And certainly in the user experience, very, very fast performance. This kind of graph that I have is a time series of the amount of traffic that goes in and out of some of our environments. Let's just put it that way. And obviously by visual inspection, you can see anomalies pop out. I mean, obviously the one I have highlighted here is something somebody should go take a look at. One we had just an abnormal amount of data traversing our environment at that time. But what's not so obvious and where real-time detectors come into play is being able to de-interleave all that data into some single channels, if you will, being able to separate it down into some real interesting single entities and events. And this is the result of one of the detectors. And what we found is that a single application in that environment had an anomaly far beyond its normal pattern, more so than what you saw here just by visual inspection. And by interpreting that event, the source of all that information was from some external SSH connections. That is a no-no, obviously, if you're trying to protect your enterprise network. So that generated an alert very quickly, which resulted in some policy updates for this environment to prevent that external SSH connection from happening. So being able to do that kind of outlier detection and de-interleaving of that data down to a verified alert, that's what we've got to get eyes on. Very simple example, but a very effective one here using the infrastructure that we've talked about. Another example, let's talk about moving data from simple statistical model into this entity relationship model. So what we have here is a histogram of our top interactions that go on to our network. And it's interesting to see that there's 10 different users here on our network that kind of top the list. But what's more interesting is to move to this graph analysis to see how they're interacting with our network. And being able to move into that entity behavioral model of how are they behaving, being the top consumers on our network, how are they behaving with all the different elements. And that takes modeling, the graphing and linking of data capabilities that Adam described to be able to then assess whether we have some things to look at. And what emerges is some detectors that takes those top performing groups and does statistical baselining on them and sees if there's some anomalies in the behaviors they have with our network. And what we found here in this example was that there was some non-human behavior going on in the number of logins that were being attempted for any very small time window. And the interpretation is, hey, these are not possible in 15-minute time buckets that we do our analysis in for somebody to try to log onto our network some 280 times. That generated an alert immediately that, hey, we need to go take a look at this and probable corrective action needs to be taken. So that's another example of these real-time detectors and interpreters. The most, say, graph-intensive analysis that we've done or I've been associated with lately is this one in the insider threat use case. That is being able to understand, again, how does a user interact with all the different elements. In this graph, we have a user in the center of the world. We have his interaction with his ISP, that interaction with VPN servers, and all the relationships between those entities and how much data is moving forward and backwards over those kind of channels. and then again the relationship of what IP address assignment he has onto our network, so we know exactly where this interaction is happening. So that feature of the graph, being able to model it, visualize it, and be able to analyze those relationships gives us some very, very interesting graphics and opportunities to interpret some problems. And in this case, what we do is generate a statistical baseline, again, on some of these interactions, and then detect if there are anomalies against the statistical baseline. So does this behavior violate some standard deviation window, which we would say, hey, is anonymous, an anomaly. So that's exactly what we've done here, is we've baselined the user's behavior and determined there is an event that warrants some further investigation, which we would alert an analyst for him to go take a look at the source of that data. So what, again, building on what Adam said, the idea here is to get the eyes of an analyst onto the right potential threat by doing the detection and interpretation as early and as in an automated fashion as possible, so that remediation and corrective action can be taken. Okay, so that's what we have. So I've talked about the Hadoop-based threat analytics platform, a little outlier detection and interpretation, and now open the floor up to questions. Sir? What we presented to you was just an industry standard network. So yeah, users on a large scale enterprise network. And all this is anonymous data, so I won't attribute to anything. Yeah. But it is a very large scale enterprise network. Right. It was real data. Questions? Yes? There are lots of examples, none of which I can share. So I've shared what I can share. There's a lot of work in that area. Maybe sometime we'll be able to bring that to you. But he was asking if there's some supervised machine learning algorithms going on here in this presentation. And the real answer is no. Most of this is statistical analysis, standard statistical analysis. The abilities we have to do supervised learning are in this architecture. It's just not something I shared or could share today. Yeah.
If you want, I can take some of that and talk about some of the work that we're doing. Okay, so I can talk about a little bit of the work that we're doing to bring in some unsupervised techniques into this as well. So a lot of the data that we're working with now is DNS data. Right? DNS data has a lot of uses for it. There's the DNS protocol where, if you're analyzing, if you're just using DNS, like it was intended when it first came out 30 plus years ago, it's pretty simple, right? It's a simple protocol. You take your domain name, you look up an IP address, and then you're off and running. People have gotten creative with DNS. So companies like Google and Facebook and others have started encoding data into the domain names themselves, right? Which is great. I mean, they can do a lot of cool things with it. But if you're trying to analyze it from a security perspective, that's really tough because other people are also doing interesting things with DNS data, right? Like tunneling, right? If I want to exfiltrate data from a network, I can take DNS data and put in a seemingly random set of characters that's actually encoding some information or maybe an encrypted bit of information. So if I want to distinguish between all of these different classes of users of DNS data, that's a tricky problem, especially if I don't know all of the ways that people are using this, sort of normally. So if you bring in factors like, entropy or just kind of the number of times DNS domains were used, you can start to create these feature vectors, right, that have a bunch of interesting characteristics. Pull those together, you can start to bring together classes of uses of DNS, and then coupling that with kind of known bad, you start out with unsupervised clustering and then start doing analysis on the interesting clusters. So that's one of the ways that we're bringing in that type of unsupervised learning into this space now. And really, it's built on that general organization of data into a network model where instead of looking at all of these logs, you're looking at a higher level statistical view of it that includes time series and includes relationships.
Great question. Thanks, Adam. What else do you have?
What reason do we use Accumulo over HBase or Cassandra?
He was co-founder of Apache Accumulo. No, I'm kidding. No,
Well,
I'll give you two. I'll give you two just from my perspective. I'm talking on the application side, so more so than being a contributor. But the write performance of Accumulo is remarkable. It far exceeds that of HBase. And has for some long time. HBase read performance, maybe a little better caching going on that side of it, but the write performance of Accumulo is unmatched. The cell level security is also unmatched and has been for a long time. So we talk about not only labeling, but logical operators and very complex expression in terms of protecting cell level data. Those two things alone have driven me to be an application developer around Accumulo for about 8 years now. So it's very good key value store, very capable, and has a lot of other features.
Yeah, and I'll say HBase and Cassandra are also great data stores. They all have elements that they are the best at. If we're talking about write performance, which is a very dominant factor in what we're trying to do, that was a huge reason for us picking Accumulo as the core of our system. Besides our familiarity with it, having come from an Accumulo background, the way that we organize things into time series and statistical aggregations also fits very naturally into the way that Accumulo uses iterators. And without going into a huge talk about Accumulo's architecture, probably suffice it to say that that's a dominant element here. There are similar things that you can do in HBase, but not as many people do it, so it's kind of a maturity issue there.
I'll give you my application level,
Yeah,
and then
so
he'll.
Just to repeat the question, does Accumulo accelerate the ability to do graph analytics and gain insight from graph analytics?
Yep, and a little. So from my perspective, graph analytics is about understanding how things behave between different entities, right? So it's not just a sequential search through data. It's a very smart search through data through the kind of indexing and linking of data that Squirrel Enterprise does inside of Accumulo. So it's a way to traverse data very smartly. So for an application developer, when I'm writing graph traversal algorithms, I'm not looking at something scanning tables and rows of this data. I'm looking for relationships, and that gets me to the kind of data I need really, really fast. And accessing data in that style Accumulo excels at. And so I'll let him tell you how that works.
Yeah, so from an architecture perspective, we're using Accumulo as a graph store for doing graph analytics on top of it. We've used Spark. We've used other kind of custom-built graph analytics. But just to speak to the graph store side of the house here, the core thing that you get out of Accumulo is denormalization of graph neighborhoods. Right? So if I want to quickly find a neighborhood, in Accumulo, the way we store that in a graph, it turns into a key range scan. And if we're talking about kind of traversing a one hop on a subgraph, that turns into a parallel multiple range scan. But it turns into a very efficient operation on Accumulo. So coupling graphs and kind of time series features on graphs and features on entities. So basically a property graph model. Accumulo is a very natural store for that, and it enables
the analogy is that this technique brings random access to big data. I mean, that's really what it is. It's no longer sequential access and trying to do these huge deep learning out. We're talking about almost random access to these small ranges of related data. And so I can get through these somewhat complex queries in milliseconds and plot these kind of related graphs.
Can that be done in the open source version? Yes. In fact, there are open source graph libraries built on top of Accumulo. One was recently released. It's called RIA. It's RYA. And yeah, a lot of people have built graph databases on top of the open source Accumulo. It can also be done on other key value stores. Accumulo has some support for very large rows, which can be nice when you're talking about graphs that have distributions like power law distributions where one node might have a lot of neighbors. So there's some scalability aspects that make Accumulo particularly nice. In the blue. That's you. You're wearing blue. What kind of man hours have we put into the project?
You talking to me, AT&T, or him building Squirrel Enterprise? AT&T. Well, Josh, how many hours have you worked lately? Let's see. This project, when we're moving into a big data-based threat analytics platform, I'm going to say a team of 6 size programmers for the last couple of years. Might have gone up to 8 to 9 at some time. Yeah, so right now that's probably, including myself a lot, that's probably about 4-ish. And our clusters, we have 4 of them. We have 4 of them, and some of them are quite large and out into production supporting real SOCs and a lot of data. So, yeah. Mm-hmm.
Yeah, so how are we bringing data into Accumulo? The Squirrel basically wraps Accumulo and does a lot of processing, pre-processing to organize that log data and graph model and build indexes and all that. Basically, the work that we're doing is largely built on top of MapReduce. So we'll take a small chunk of data, kick off kind of like a minute-long MapReduce job. Some of them are smaller for bringing in kind of quicker data sources, but MapReduce creates a file that then gets bulk loaded into Accumulo for most of it. Main reason for that is basically to keep our statistics correct under failure. We kind of do things in small chunks, small batches.
And building on top of that, we create job configurations that reiterate that over and over again really fast. So it's not just sit around and wait for data to show up and we'll get to it and adjust it when we can. This runs at a very high frequency.
Yeah, we were just talking about upstream processing as
Yes.
well. So some of our customers use Flume and Kafka to bring data in, be data driven all the way up to the source. And I think, Bob, I don't know if you want to speak to that, but you guys are working on similar platforms right now.
Right, and some of that is very challenging on the enterprise scale that I've presented here. I mean, no doubt there's many, many virtual machines, many, many sources of information. So there's a lot of different jobs running at any one time ingesting data, whether it's streaming through a Kafka infrastructure or other file-based infrastructures. We cause the frequency of those ingest jobs to happen very fast. So hence we get a very timely graph of data, very timely analysis of data. Is it micro batching? Not really, because some of these files are huge, but we got to process them as fast as we can get them onto the platform. What we really manage, and something I didn't have time to spend here, is the key performance indicator is that data latency. How much time do we inflect into the data that prevents access to analysts or prevents access to detectors and interpreters? That's got to be managed. We measure it and we manage it to minimize it. Okay, yeah. That's a great question. So he's asking, do we have real-time reactions? So basically, our concept is to do an automated feedback loop of remediation, yes? And there is a lot of work in that area right now. The focus is, if you remember that cognitive graph I put on right now, the real focus is on detection and interpretation. We have to interpret these events correctly. We can't tell analysts, hey, this is an event when it turns out to be a false positive. The next step will be that automated remediation loop. We haven't quite got there yet. It is basically an alerting system, getting eyes on the right graph. Yes.
Yeah, let me take that one also from the perspective kind of more generally the ecosystem of security analysis tools. There are a lot of systems that are trying to do, rule-based chain systems that, include some of that automated feedback. A lot of what we're trying to do is provide, search for bigger behaviors. And when you're looking for bigger behaviors, there are more false positives. So you don't necessarily, you don't necessarily directly want to take action on that without somebody seeing it. But there are also things that tend to show up over slightly longer periods of time. So having a human in the loop isn't necessarily bad in those setups. But where we do find, some of the feedback, some of the things we're trying to detect are things that show up in a short period of time and are things that are very high fidelity, very low false positive rate. Those things we would feed back into another system, just from a Squirrel perspective, like a SIM system to do the automated, remediation triage. So what's the cause of the false positives when you're looking at these things? So if we go back to my DNS example, a lot of people are using DNS in creative ways, right? So a false positive might be, somebody's just using it in a way you didn't anticipate before. But really, as people get more creative and more applications, just exist in an infrastructure, enumerating those and understanding the behavior of all of those becomes a complex problem, and there are more places to hide, basically. So, there's kind of this natural possibility that more false positives occur, and we tend to take, a ranking approach, a risk-based approach to analyzing that. There's still some work to be done on, automatic actioning from that type of system.
And that is the key, though. You've hit on the key right there, is not alerting and taking action on something it's not a valid threat. And that is the focus of the automation right now for us. Yeah. I think you had another question?
Yeah, kind of a two-part. One is there anything in the cloud, and do you do bare metal or VM exclusively?
The answer to all that is yes. So.
Right, so is it in the cloud? And
is it in the cloud? Is it bare metal? Is it virtualized? The kind of network that we're talking about is all of those. So we have some that are huge bare metal infrastructures. We have a huge virtualized environment. Yeah, massive.
Yeah, and I would say most of our customers are on bare metal or some type of private cloud. A lot of our customers are not looking to put their most secure information up on the cloud right now. So, that's still an issue. But I think, as we scale this up to reaching businesses that don't have the capability of standing up their own, set of servers that are constantly monitoring it, and they want to offload that to the cloud, a bunch of managed security services providers are starting to take on that load of which AT&T is one. So it's kind of a trick question to ask Bob if he's doing stuff in the cloud, because he is the cloud.
We are the cloud.
Right, in some sense. Are they tokenizing it to reduce the sensitivity? Are you guys doing any of that? I don't know.
Oh, yeah. Yeah, we can't really discuss the details of some of those things. Yeah, absolutely. Yeah, data sensitivity governance is a big deal. So it's certainly to offer to the AT&T customers. I know it's lunchtime. If you guys want to talk, I'll be around here, so I'm sure Adam will too. You can look me up on LinkedIn or Twitter, and any other follow-ups I'd be glad to take on.
Thanks.
Thank y'all.